Hello, folks. This is Andrew. If you follow me on LinkedIn, you know I'm a big supporter of AI and machine learning. Unfortunately, there's a lot of misconception in the venture capital and investing community at large about what machine learning really means. What I want to do through a series of educational videos is to highlight concretely what is machine learning. That said, let's play around with a tool called TensorFlow Playground, which I will include a link in the comments section below. So the problem we're trying to solve today using machine learning is cancer diagnosis. Let's say you're a healthcare provider and we have a lot of patient data on cancer cases based on tumor size and patient age. The solution we're trying to develop based on machine learning is to provide an accurate diagnosis of new patients based on just these two parameters. Obviously, in the real world, we will have many more parameters, but just use a simple example to start. What I mean is that this problem can be easily generalized to any number of different parameters, in fact. So what you have in the chart here on the right is showing you two different data sets, the orange and the blue. Think of the orange as those cases where the diagnosis is benign, i.e. the patient doesn't have cancer, and the blue dots representing those cases where the patient does have cancer, where the tumor is malignant. So the x-axis can be thought of as representing the tumor size from small to large, and the y-axis can be thought of as representing the age from younger to older. So this clearly shows a trend in tumor size. So the larger the tumor size, generally the higher the probability of it being cancerous. And in age, the older you are, the more likely you are to have cancer. So fairly common sense intuition here. But what this machine learning model would do is will establish a rigid representation of this and will be able to accurately classify any future patient data that will be coming in and accurately classify that. So there's a few different parameters we need to adjust for this model to work. I don't want to get too deep into the details of these parameters. They include items like the learning rate, the activation function, the regularization function, and the regularization rate. What I want to focus more is on the simplicity of the model given this data set. So we just are using the two different features and one hidden layer of this neural network that is at the core of this machine learning model. So I'll stop there and let's see what happens based upon these parameters. Yeah, that's it. So that was quite anticlimactic. I'll pause right here, but what you see is a quite rapid convergence of the model. And the way we see that is that the loss function has approached a very, very small value. So that basically means that the data and the model are in close alignment, and you can clearly see that in the graph here where there is a very sharp classification between the orange region and the blue region, indicating that the model is doing a very good job of classifying those cases that are cancerous versus those cases that are not cancerous. So this is a very well defined model that can be used now to classify new patients for the hospital based upon these two parameters. In the next episode, what I want to do is a more complicated example like this one here, where you see that the data between the two different data sets is quite intermingled. Hence, one way of interpreting this is that the representation isn't great in terms of data we're seeing coming in, which is representative of actually many interesting problems in real life. So this is a a very good example to highlight in the next episode. So stay tuned, and I'll see you shortly.